Yeah. Woo! Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Step in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. We ain't slowing down, the party's just begun. Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, hey, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're busy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every interaction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Yo, check it. Said you're on a candy spree. Bubblegum dreams set the sugar free. Lollipop flavors, mix them all night. Cotton candy skies in the neon lights. Snap back, glow up, shine like a jewel. Boys too sweet, breaking every rule. Drip that caramel smooth and slick. With the sugar kings, better take your pick.
Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're busy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction, melting hearts with every direction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop. Sprinkle starlight, dripping chocolate rain. Every heartbeat calling out your name. Spin the world, let the colors ignite. Sugar rush, taking over tonight. Sugar rush, keep it on replay. Party never ends. We can dance all day. Turn it up, the beat won't stop. We're fizzy like soda. Pop, pop, pop. Sugar rush, taste the sweet reaction. Every move's a sweet distraction. Feel the buzz, don't ever drop. We're sweet like candy. Pop, pop, pop.
Sage your boys, popping non-stop. Sugar rush forever. Pop, pop, pop. Man. Yeah. Woo! Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Step in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. We ain't slowing down, the party's just begun. Sip, sip, take a little taste. Heartbeats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night.
candy spree. Bubblegum dreams set the sugar free. Lollipop flavors, mix them all night. Cotton candy skies in the neon lights. Snap back, glow up, shine like a jewel. Boys too sweet, breaking every rule. Drip that caramel smooth and slick. With the sugar kings, better take your pick.
Sip, sip, take a little taste. Heart beats faster, no time to waste. Colors swirling, lights collide. We ride the sugar wave all night. Sugar rush, popping like confetti, dancing crazy. Yeah, we're always ready. Turn it up, the beat won't stop. We're busy like soda. Pop, pop.
All right. Good evening, guys, and greetings to you wherever you are watching us from, and welcome to Shocking Hour episode 25. Today, we have a very interesting set of questions that we want to try our hands on. These are a little bit tough mathematical expressions and physics questions that we will be doing. But all the same, I believe you guys are awesome, you guys are amazing, and we will be solving all these problems together. All right, so without further ado, I will start by writing the questions on the board or on our screen so that we can see and start trying our hands on the question. So guys, if you are here and you're watching, please let me know your name and where you are joining the stream from. Okay, but more especially where you are joining the stream from. That will be awesome. Are we okay? All right. Okay, so let's start with a very simple expression for today. Let's start with that whilst we wait for you guys to engage with me. So over here we have to find, okay, wrong pen. Okay, so here we have to find the value, of a cube plus 2ab squared plus b cube when a is equal to 2 and b is equal to -1. Okay, so this is the question that we have. So we have possible options. Option A is 9, option B is 11, option C is 12, then option D is 13. Okay guys, so let's quickly try our hands on this particular question and let's see what we will have as our answer. So we have to find the value of a cube plus 2ab squared plus b cube when a is 2 and b is -1. So that is the problem, the first problem that we have for today's stream. So please, let's try our hands on it. So guys, we have 1 minute to try our hands on it, and let me know the answer in the live chat. So if the answer is A, just type A in the live chat. If it is B, just type B in the live chat, and so on and so forth. Okay, so like I said, we have 1 minute. We have our 30 seconds gone already. So we have some few seconds more, and then we'll solve it together. Okay, beautiful. So let's look at the solution to this particular problem. So I'll write down my solution here. So here we only need to do a simple substitution in here to get our answer for this particular problem. So in this case, the term or the equation given to us is a cube plus 2ab squared plus b cube. Are we okay? Now don't forget that the value of a has been given to us to be 2 and that of b has been given to us to be -1. So we substitute these two parameters into the expression that we have. So our a here will now be 2 cube plus 2 multiplied by a, which is 2, multiplied by b, which is negative 1 squared, plus b, which is negative 1 squared. Are we okay? Now, from here, I'll still maintain my 2 cube, then plus 2 multiplied by 2, then the negative 1 squared. Negative 1 squared will give us 1. It becomes positive. Then over here, negative 1, sorry, this is supposed to be cube. Negative 1 cube over here will still give us negative 1 over here. So from here, I can proceed to find my answer. So over here, 2 cube is going to give me 8, plus 2 multiplied by 2, that will give me 4, multiplied by 1, that will still give me 4. Then over here, I have my minus 1. Okay, so 8 plus 4, that's going to give me 12. So 12 minus 1, this is going to give me 11. So therefore, option B, which is 11, is my correct answer for this particular expression. Guys, I hope we are okay. Okay, so silence means concern. So we will move on to the next question. So if you don't understand anything or you want me to explain something, please just let me know in the live chat. So over here, we are to make H the subject. We have to make H the subject of the relation. Make H the subject of the relation. V is equal to 1 over 3 pi r square h. Okay, so you have to make H the subject of this relation. So our possible options here, we have option A to be 3v over pi r square, Option B is 3 pi v over r squared. Option C is 3v over r squared. And then option D is v over 3 pi r squared. Are we okay? So guys, this is the question. We have to make H the subject of this particular expression. Please, let's go ahead and do that. So anyone with the answer for me? Guys, anyone with the answer? Okay, very good. So let's proceed to look at the solution to this particular problem. Okay, in this case, we write down our solution. So what we have here is V is equal to 1 over 3 pi r squared h. Okay, this is what we have. Now, the first thing we notice is that we have a fraction in this particular expression. So we want to get rid of the fraction so that we can be able to solve easily. Now, don't forget that on your right hand side, everything there are multiplying. They are multiplying each other. So what we will do here is that we'll multiply through by the LCM or the denominator of this particular fraction, which is 3. So I'll multiply all sides by 3. So here will become 3 multiplied by V is equal to 3 multiplied by 1 over 3 pi r square h. That is what I am going to have. Now 3 multiplied by V will give me 3V, and this is equal to 3 multiplied by 1/3, or the 3 here will cancel the 3 here, so we only have 1 there. 1 multiplied by everything is still the same. So we'll have pi r square h over here. Now remember, the question demands that we make h the subject. So to make h the subject, we need to let it stand alone. We do that by removing any other parameter that is around it. So we divide both sides by pi r squared. So the same here, pi r squared. So this will nullify this. So our h is now equal to 3v over pi r squared. And if we look through our possible options, we can see that option A is indeed the correct answer over here, as we also have 3v over pi r squared. Are we okay? All right, amazing. Now let's proceed to look at more questions on this. So I have here, if 2 over, let me erase this, if 2 over a is equal to 1 over b minus 1 over d, we have to find an expression, for d in terms of a and b. Are we okay? So our option A here is b over a minus 2b. Our option B here is a over 2b minus a. Our option C here is ab over a minus 2b. Then our option D is 2ab squared minus a squared b. All right, guys, so this is the possible options for this particular question. We have, if 2 over a is equal to 1 over b minus 1 over d, we have to find an expression for d in terms of a and b. Basically, it means make d the subject. Okay, so if we have this expression, what is the answer? So Vishal is here. Thank you so much for joining, Vishal. Vishal is saying option C. So let's go ahead and see if that is indeed the correct answer. Okay, so let's write down our solution. So I have here 2 over a is equal to 1 over b minus 1 over d. Remember, I am supposed to make d the subject, and I have d over here. So what I'll do is that from here, okay, I'll send d, 1 over d, to the other side of the equal to sign. So I'll send 1 over d to the other side of the equal to sign. Okay, I'll send 1 over d to the other side. So I'll have here 1 over d to be equal to, the 1 over b will still be here. Then it will become minus 2 over a over here. So from here, I now have this expression. I can find their LCM. The LCM here. Okay, Ganga, thanks for joining. This is the question that we have on the board. So we are trying to find the solution to it. So I have here b and a. Yeah, Ganga, welcome back. So b and a will be my LCM here. So b will go here, a multiplied by 1 will be here. Then minus this will go here, b. So b multiplied by 2 will be here. And all this is equal to 1 over d. So this expression will now be equal to 1 over d is equal to a multiplied by 1 is a, minus b multiplied by 2 is 2b, all over b a. So from here, I can cross multiply. So I will have d multiplied by a minus 2b. Okay, that is, this will multiply this, and the 1 will multiply this. So this will be equal to ba multiplied by 1, which is still the same. So from here, I want to make d the subject, so I will not expand. I'll just divide both sides by a minus 2b, a minus 2b. So this will cancel this. So my d is equal to ba over a minus 2b, or ab over a minus 2b. And that is exactly what Vishal said is the correct answer. So option C is the correct answer over here. Very good. Now let's proceed with the next question. Okay. So here, in the next question, we are to make T the subject of this particular expression. So make T the subject. Make T the subject of the relation. Make T the subject of the relation. We have here L is equal to G into brackets T over 2 pi squared. Okay, this is the expression that we have. So let's look at our possible options. We have A is T is equal to 2 pi the root of G over L. We have option B, T is equal to 2 pi the root of L over G. And we have option C, T is equal to 2 pi L over G squared. Then option D, we have T is equal to 2 pi G over L squared. Okay, so this is the possible options that we have. Let's work on it. Okay, so Ganga is saying option B. Vishal is also saying option B or K. So you guys are saying option B. Let's look at that quickly. So we proceed. Okay. All right. So from here, we are supposed to make T the subject, which is what we have at the top over here. So we have L is equal to G into bracket T over 2 pi squared. The first thing, I want to get rid of the G over here so that I have T over 2 pi squared as my only expression over here. So I divide both sides by G. So here by G, here by G. So this will cancel this. So I have L over G will be equal to T over 2 pi. Okay. All this guy will be squared over here. Are we okay? Now from here, I have this. I want to get rid of the square over here. So I bring square root in here. So I'll have square root of L over G will be equal to the square root of this guy T over 2 pi all squared. Are we okay? So this will get rid of everything over here. So we have here the root of L over G is equal to T over 2 pi. Sorry, this is T, just T. Okay, so to make T the subject, we cross multiply. In this case, I'll just leave the T here and then use this to multiply all that I have over here. So therefore, it means that my T is equal to 2 pi multiplied by the root of L over G. Okay, and if we look through the possible options, option B is the question that gives us that particular answer. So you guys are correct. All right, so let's have a look at other questions, a little bit more complicated. So we have if 2 into bracket kx plus 6 is equal to 6 plus 8x, find the value of k, find the value of k when x is equal to 3. So we have here option A is 4, option B is 3, option C is -3, then option D is -4. All right, guys, this is the new question that we have. We are they said if 2 into bracket kx plus 6 bracket close is equal to 6 plus 8x, we have to find the value of k when x is 3. Vishal is saying B. Okay, what do you have for me, Ganga? Okay, Ganga is also saying B. All right, so both are saying B. So let's look at the solution quickly. So we have here 2 into bracket kx plus 6, and this is equal to 6 plus 8x. And we've been told that x is equal to 3. So we do that substitution. We'll have 2 into bracket 3k here plus 6, and that will be equal to 6 plus 8 into bracket 3 over here. Now 8 multiplied by 3, that will give us 24. So we have here, if I expand this bracket, I'll get 6k plus 12 here is equal to 6 plus 24. So this side will now give me 30. This is 6k plus 12. So obviously, I'll send my 12 to the other side of the equal to sign. So I have 6k here will be equal to 30 minus 12 because I brought a positive 12 here to the other sign. Okay, very good. So Vishal is saying something. So here we have 18 here. We divide both by 6, and then the value of k will be 3. Are we okay? So yes, the correct answer is 3. So Vishal is saying, sir, let us do some difficult question as you want physics or maths. Okay. So Ganga, are you okay? We want to switch to a more difficult questions like physics and co. Are you okay? Can you do it? Are you up with this? Ganga, if we switch to physics questions, okay. So Ganga is okay with it. So let's move on. Let's continue with what we were doing yesterday, current electricity. Let's look at some complicated questions on electricity. Very good. All right, so let's proceed. So we have here okay, so I have here a wire of length 2 meters with cross-sectional area 9.0 times 10 raised to the power minus 9 meters square, carries a current of 1.5 amperes. So we are to calculate the potential difference, across its ends. Take into consideration that the resistivity of the material of wire is 1.8 times 10 raised to the power minus 8 ohm meter. Okay, so that is the question we have here. Option A is 1.5 volts. Option B is 3.0 volts. Option C here is 4 volts. And then option D here is 6 volts. Are we okay? So here the formula, in case Ganga you have forgotten a little bit, let's refresh your memory. So the resistance is directly proportional to the resistivity multiplied by length over the cross-sectional area. Are you okay? All right, so this is just a small question. Let's try our hands on it. Okay, so Vishal is saying 6 volts. Okay. Anyone else? Ganga, what do you have for me? Ganga, what do you have for me? Ganga, you have 1 minute, after which we will solve it together. Okay, so let's have a look at the solution to this problem. So like I said, the resistance of a wire is directly proportional to the resistivity multiplied by length all over the cross-sectional area. So it means that the resistance is directly proportional to the length over the cross-sectional area, and then the constant of proportionality is what we are calling the resistivity over here. So now if you look at the question that we have, let me write down the solution. If we look at the question that we have, we've been given the length in the question to be 2 meters. That is, length is 2 meters. And then the cross-sectional area has also been given to us. So our area is equal to 9.0 times 10 raised to the power minus 9 meters square. Are we okay? And then we've been given a current I to be equal to 1.5 amperes. So we have to calculate the potential difference, or basically the voltage over here. And then we've also been given the resistivity to be 1.8 times 10 raised to the power minus 8 ohm meter. Okay, so right from here, all we need to do is that use this formula. Resistance is equal to resistivity multiplied by length all over cross-sectional area. We do the substitution to find the value of R, and then we use the Ohm's law. V is equal to IR to find the voltage. So from here, we have the resistivity, which is 1.8 times 10 raised to the power minus 8, multiplied by the length, which is 2, all over the cross-sectional area, which is 9.0 times 10 raised to the power minus 9. Okay, so if we compute this into our calculator, we are going to get our resistance to be equal to 4 ohms over here. So this is what we will get. So from here, we find our voltage. Now our voltage V is equal to IR, which implies that our voltage is equal to the current given to us. And then we found out that the voltage is 4. So over here, our voltage is, our resistance is 4, sorry. So we just multiply 1.5 by the resistance, which is 4 over here. And that will give us the voltage value of 6. So we have 6 volts as our answer. So yes, the correct option here is 6. Ganga, please, I hope you will understand. Ganga, are you with us? I believe so. Okay, so let's look at another question. So I'll be switching between physics and mathematics. Now, I have here the fourth term of a linear sequence. The fourth term of a linear sequence is 19, and the 11th term is 54. Find the 8th term. Find the 8th term. So I have here option A, I have 5. Option B, I have 33. Option C, I have 39, and then option D, I have 44. Okay, so let's quickly attempt this question. Okay, so Vishal is saying 39. Okay, anyone else? All right, so let's quickly look at the solution to this problem. So it seems we've lost Ganga, but we'll wait for his return. Now, over here, to find the unknown, it is equal to A, which is the first term, plus n minus 1 multiplied by D. The n is the number of term, and then the D is the difference. So Simon is here. Simon is saying 39. So Simon, thank you so much for joining. Let's look at the solution together. Now, over here, we're told that the fourth term, which is U4, is equal to 19. And then the 11th term, which is U11, is equal to 54. Okay, so from here, let's do the individual substitution, get two equations, solve them, find the difference, and then we can use that to find the 8th term. So if I'm using U4, it means that U4 will be equal to the first term, which I do not know, so I'll leave it as A, plus I know that the number of term here is the fourth term, so 4 minus 1 multiplied by the difference, which is D, and this is equal to 19. Okay, so I have here A plus 3D is equal to 19. So I can make this as equation 1. Now using U11, I will have A plus 11 minus 1 multiplied by the difference. That will give me 54. So A plus 10D will give me 54 over here. Are we okay? So I can leave this as equation 2. So from here, I can just solve them as simultaneous equations. So I'll say equation 2 minus equation 1. That means I'll have A plus 10D is equal to 54 minus equation 1, which is A plus 3D is equal to 19. So over here, the A minus A will give me nothing, which is 0. Now, 10D minus 3D will give me 7D, and this will be equal to 54 minus 19. 54 minus 19 will give me 35, so I have 35 here. So therefore, it means that 7D is equal to 35. If I divide both sides by 7, my difference is going to be 35 on 7, and that will give me 5. So it means that the difference here is 5. So now that I know the difference, I can go ahead and substitute the difference into one of the equations to get the first term. So if I do that, let me substitute this into equation 1. So I'll have A plus 3 multiplied by 5 is equal to 19. So A plus 3 multiplied by 5 is 15, and this is equal to 19. So therefore, the value of A is 19 minus 15. And so therefore, A is equal to, this will give me 4, I believe. And yes, that should give me 4. So now that I have my first term to be 4 and then the difference to be 5, I can proceed to find the 8th term. So the 8th term in this case is going to be U8, and that is equal to A plus n minus 1 multiplied by D. And then the first term here is 4, plus we are finding the 8th term, so it is 8 minus 1 multiplied by D, which is the difference, which is 5. So that will be 4 plus 7 multiplied by 5, Are we okay? And then 7 multiplied by 5, that will give us 35. And 35 plus 4, that will give us 39. And so therefore, our correct answer over there is 39, as rightly said by Vishal and Simon. So you guys are all correct, 100%. Okay, so the correct answer here is 39. Brilliant. So let's quickly look at another question. So I have here the first and second terms of a linear sequence are 15 and 12 respectively. So we have to find the nth term. Okay, so guys, let's quickly solve this whilst I look for tougher questions for us. Option B is 12 plus 3n. Option C is 12n plus 3. Then option D is 11 minus 2n. Okay, so let's solve this whilst I look for more tough questions for us. Vishal is saying A. Okay, Vishal is saying A. Simon, do you have anything for me? Simon, do you have anything for me? Okay, so yes, guys, the correct answer here is option A. I'm going with A also. Yes, the correct answer here is A. So once we have it correct, there's no need I solve this problem. So let me look at a different question, a little bit more complicated. All right, so this is question 1. Let me give you question 2. Find the sum of the odd integers from 1 to 49 inclusive. Okay, so we have option A here is 525. Option B is 600. Option C is 625. And then the last option is 1225. Okay, Vishal is saying 600. Okay, Simon, what do you have for me? Okay, so Vishal, let's quickly look at this because I'm having a different answer here compared to what you have. Are you okay? Okay, so let's look at the solution together. Question. Okay. All right. So we've been told that yes, it's actually 625. Okay, yes, it is 625. All right. So now that you have it right, I don't think we need to go through. Since you have it right, let's quickly look at the next question that we have for us. So let's move on to the next question. Okay, so I'll move on to the next question then. Don't worry, it happens. It happens when you are solving maths. It happens. All right. So I have here the sum of the second, the sum of the second and fifth terms of a linear sequence is 6, and the common difference is -2. What is the first term? What is the first term of the sequence? Okay, so this is the question. We have option A is 4, option B is 6, 7, and then 8. Oh, wow. You are saying 8. Wow. Yes, indeed. The correct answer is 8 over here. You are right. So let's move on to another question then. Let's move on to another question. Okay, so find a tougher one for you. So I have here the sum of the first four terms of a linear sequence is 28. The sum of the third and fourth terms is 22. Find the common difference. Find the common difference. So I have here option A is 4, B is 6, C is 16, and then D is 50. Okay, yes. So the common difference is option 4, and that is correct. All right, so let's look at another question. So here, this is a physics question. So we have this diagram. Okay, so this is what we have here. We have here 6 ohms. Here is 4 ohms. This is 1.6 ohms, and this is 12 volts. So one, calculate the voltage across the parallel resistors. Okay, so for this one, the options are 12 volts, B is 7.2 volts, C is 4.8 volts, and then D is 4 volts. And then the second question for this is the current registered by the ammeter. So for that one, the options are 4 amperes, 3 amperes, 1 ampere, and then D 0.3 amperes. So Vishal, you are saying the first one is A, and then the second one is B. That is what you are saying. So let's see. Uh, Yes, the second one is B. So there's 3. Then there's the first one is not really. The first one is not A. So let's look at what I have here for the first one. Okay, so let's look at what I have here for the first one. So we know that these two resistors are parallel. These guys are parallel. Okay, so to find the total resistance, it is 1 over R is equal to 1 over 6 plus 1 over 4. Are you okay? And if you solve all of this, you are going to get your R to be equal to 2.4 ohms. Please, do you have this, the resistance for these two resistors in parallel? Do you have 2.4 ohms? You are saying 4.8. Are you sure? So just a minute. I have the ratio 1 over 6. So 1 over 6 plus 1 over 4. So this is going to be 1 over 4. So this will be 5 over 2. This will be 5 over 12 is equal to 1 over R. So therefore, our R is going to be 12 over 5, which is 2.4 ohms. Are you okay? Yes. So this is supposed to be 2.4 ohms. So from here, now that we have this, we need to find the total resistance, because they are saying we should find the voltage across just the parallel resistor. Okay. Now we know that this, if we merge these two, then the whole circuit becomes something that looks like this. So here, the parallel one becomes this becomes 2.4, and then this becomes 1.6. Are we okay? So they become series once we calculate the total resistance for this guy. So it means that if they are in series, our resistance will be equal to 2.4 plus 1.6, which is equal to 3 ohms over here. So from here, the voltage across this parallel resistors, okay, we know that the voltage is the same across in series. So the voltage will be IR, which in this case, the current okay, the current, which is 3, multiplied by the, just a minute. So now that we have this, we need to first of all go ahead and find, we have our this, so we need to find the current flowing through, so that we know voltage is equal to IR. So 2.4 plus 1.6, yes, I agree, it's 4 ohms. Thank you. This is 4 ohms. Thank you so much. So from here, we need to find our current. So our current, I, is equal to voltage divided by the resistance. And then the voltage over here is 12 divided by the resistance, which is 4. And this will give us 3 amperes. Are we okay? This becomes 3 amperes. So now that we have 3 amperes, we can go ahead and find the voltage across just the parallel resistor over here. So the voltage across this guy alone, let me highlight that. The voltage across this guy alone will be V is equal to IR. Okay. Now, remember, in series, the same current pass through, but the voltage is different. Okay, so the voltage across this particular one will be the 3, which is the current over here, multiplied by the 2.4, which is the resistance over here. So this will be 3 multiplied by 2.4. And then if I do that into my calculator, 3 multiplied by 2.4, that is going to give me 7.2 volts. Please, Vishal, do you get how come we got 7.2 as the answer for the first one? So the first one is supposed to be B. Please, do you get it? All right, awesome. But then the second one is indeed 3, so this is correct. And then this one is supposed to be B. All right, let's have a look at another question. I have here a battery of EMF 12 volts and internal resistance 1.5 ohms is required to give a current of 0.6 amperes when connected to an external load of resistance R. Calculate the value of R. So we have here option A is 4.8 ohms. Option B is 18.5 ohms. Option C is 20 ohms. Then option D is 21.5 ohms. Okay, so Vishal is saying 18.5. Yes, so let's look at that. So, solution for our audience who don't understand, when it comes to EMF or a battery with an internal resistance, the EMF E is equal to I. The resistance here becomes the sum of the normal resistor, which is R, plus the internal resistance that the battery is given. Are you okay? So from here, we can just, they say we should find the value of R, which is here. We make that the subject. So to do that, we divide both sides by I. So E over I will be equal to this plus this. So from here, it means our E over I, EMF over I, minus internal resistance will be equal to the capital R that we are finding. And so therefore, our R will be equal to our EMF has been given to us as 12. We have 12. And then they say the internal resistance is 1.5. but then the current is 0.6. So the I, which is the current, is 0.6 here, then minus the internal resistance, which is 1.5 over here. So if you compute everything here into the calculator, you have 12 divided by 0.6, 12 divided by 0.6, that will give us 20. So that will be 20 minus 1.5, and that will obviously give us 18.5 ohms as our answer. So yes, the correct answer is 18.5. All right, let's proceed to the next question. All right, so I have here the next question. A lamp is marked 220 volts, 60 watts. Calculate the amount of energy it would consume when connected to a 220 volt source for 1 hour. So I have here option A, 216,000 joules. Option B is 132,000 joules. Option C is 36,000 joules. Then option D is 864 joules. Vishal, are you with me? Okay, yes, it is indeed this. Okay, because if we look at the solution, we've been given our voltage to be 220 volts, our power to be 60 watts, and then our time to be 1 hour. Are we okay? So from here, if we look at this, we realize that power equals work done over the time taken. So over here, to find the energy consumed, that will be the work done. So work done will be equal to the power multiplied by the time taken. Are we okay? So over here, we'll convert the time into seconds. Convert the time into seconds. So we have 60 seconds making 1 minute, and then 60 minutes making 1 hour. So we have 60 by 60. Okay, so 60 square, that will give us 3,600 seconds as our time. So over here, our work done will be the power, which is 60, multiplied by our time taken, which is 3,600 seconds, and that will obviously give us 206,000 joules. So yes, the correct answer there is option A. Very good. Another question. So over here, you are to use the diagram to answer the following questions. So I have here, this is the diagram. So this is 2 ohms. This is 1.5 volts. This is also 1.5 volts. All of them are 1.5 volts each. Are you okay? So the first question is calculate the potential difference across the 2 ohm resistor. And then the second question is calculate the current in the circuit. Okay, so we have to neglect internal resistance of the cells. Okay, so this one, Vishal, I'll not give the possible options. Just go ahead and solve it and let's have a look. Yes, the current is 1.5 amperes. Yes. So this is 1.5. Yes, it's true. It's 1.5 amperes. What of the potential difference? The voltage is 3. All right, this is 3. The voltage is 3 volts. Okay, so yes, you are right. You are very right. So let's have a look at one last question. So yeah, this is what we have. So we have here 4 ohms, 6 volts, current of 1.2 amperes. So you have to calculate the internal resistance of the cell in the diagram. We have here the possible options. Option A is 1.5 ohms. Option B is 1.2. Option C is 1. Then option D is 0.7. Okay. Okay, you are seeing 1 ohms. Let's have a look. Okay, that is correct. That is correct. So we have the EMF of the cell is I, the resistance plus the internal resistance. So the voltage or the EMF here is 6. That is equal to 1.2 into bracket 4 plus R. Are we okay? So from here we will have 6 is equal to 1.2 multiplied by 4. 1.2 multiplied by 4. That will give us 4.8 plus 1.2 R. Small r over here. Okay, so we have 6 here minus 4.8 is equal to 1.2 R. So 6 minus 4.8, that will give us 1.2 is equal to 1.2 R. So we want to find R, so we divide both sides by 1.2, and so therefore our R will be 1 ohms, because this will cancel each other to give us 1. Are you okay? So very good, very good. All right, so I'll give you one last question and then we end it today. So I have a very interesting question here. I just have to give it to you. So we have here a 4-volt battery of internal resistance 2 ohms is connected to 2 resistors of resistances 10 ohms and 20 ohms in series. You have to calculate the potential difference calculate the potential difference across the 20 ohm resistor. Okay, so we have option A is 1.25, option B is 1.50, option C is 2.5, then option D 2.75 volts. Okay, okay, you are having 2.5 volts. Let's have a look at that. Question number 43. Okay, yes, you are 100% correct. Are we okay? So let's quickly have a look at the solution to that. So we've been told that a battery of 4 volts. So solution, our voltage here is 4 volts. The internal resistance small r is 2 ohms. It's connected to two resistors of resistance 10 and so we have R1 is 10 ohms, R2 is 20 ohms, and they are in series. We have to calculate the potential difference across the 20 ohm resistor. Okay, so first of all, we need to find the current that is flowing through. So we use EMF is equal to I, because we have internal resistance in here. But don't forget that the two resistors are in series. So because they are in series, it means that they are R total, which in this case will be equal to R1 plus R2, and that will give us 10 plus 20, and that is equal to 30 ohms. So here we have 4 is equal to I into bracket 30 plus 2. So 4 is equal to I multiplied by 32. Are we okay? Just a minute. Okay, so from here we find the value of our current, which will be equal to 4 over 32, and then 4 divided by 32, that will give us 0.125 amperes as the current. So once we know that this is the current flowing through, we can then proceed to find the voltage or the potential difference across the 20 ohm resistor, and that is fairly easy. So that would just be from Ohm's law, V is equal to IR. We already know our current, which is equal to 0.125. The resistance, they say we should find the potential difference over is the 20 ohm one. So our voltage here will be 0.125 multiplied by 20. So if I do that, 0.125 multiplied by 20, I am going to get 2.5 as my voltage. So 2.5 volts as my voltage, and that is option C, and that is the correct answer for this particular question. All right, so Vishal, thank you so much for joining and staying with me until the end of today's stream. I really appreciate you as always for joining and making the session very interactive. I'm sure it's very early in the morning at your end, but you still make time to join the stream, which I really appreciate. So if you have any colleagues, any friends who is also in the same shoes as you, and you think that the stream will be helpful to them, please let them join the stream or share the link to them with them so that they will subscribe to the channel and also join the stream from time to time. So Michelle, thank you so much. And then if you have any question, any comment, any suggestion for me, let me take them before I end the stream today. Okay, so he's saying, thank you, sir. I will talk about this to my friends. Please do, because we need more students to be engaging with me just like you are. So if I can get at least 5 or 6, 7 students who are as passionate as you and they will be engaging with me, it will really make the session more interesting and more competitive. Are you okay? So thank you once again, and then have a wonderful morning to you, and I'll have a wonderful evening. Are you okay? All right. Bye bye. Enjoy some music.
Yeah. Sage your boys on the track. Let's go. Pop it like a drop, a sweet explosion.
Step in the room, candy coated vibes. Sparkles in the air, we electrify. Drip like honey, golden on my tongue. Wings.
Sweet breeze, love, wrap me gently. Wrap me in the rhythm, so tenderly. On the palm tree shadows, we feel free. Jah bless this love eternally. Walk on the sun in the evening light. Cool breeze kiss my soul, stars twinkle bright. Your voice in on my head like a lullaby. Whispering love on the moonlit sky. You say baby hold me close, don't go. The sea I'm low while we take it slow. Heart beating soft like a reggae flow. Me know I'm weak from this glow. Sweet breeze love, rock me gently. Rock me in the rhythm, so tenderly. On the palm tree shadows, we feel free. Jah bless this love eternally. Me see a smile in a coconut shade. Sunlight paint your face like a sweet serenade. We not need much, just you and me. And the ocean humming in harmony. You say, stay here long till morning light. The moon still watching, holding tight. You laugh like rain on rooftop bright. Me heart said this feel right. Sweet breeze love, rock me gently. Rock me in the rhythm, so tenderly. On the palm tree shadows, we feel free. Jah bless this love eternally. Even when clouds roll in from the sea, me still feel safe when you're right with me. No storm can shake this melody. We love like waves endlessly. Sweet breeze love.